6-1. Law of sines. So law of sines have to deal with non-oblique triangles. Or not non-oblique. They're oblique. We're no longer in just right triangle trigonometry. Okay? We're moving beyond that. We're going to be able to do acute triangles and obtuse triangles as well. So, if you're wondering where these things came from, you can look on these 2 pages, and they kind of develop the law of sines there, but I'm not going to take that time right now. Acute triangles are triangles where all the angles are acute. We label the angles alpha, and the side A is always across from alpha. We have another angle beta. Across from beta is B. And the third angle we call is gamma, and across from that is C. The side length, alpha A, beta B, gamma C, they always go across from each other. Okay? An obtuse triangle is you just have one angle that's greater than 90 degrees. Same angle labeling and same side labeling. It's always across from each other. There we go. So for law of sines, it's all it is ratios.
But they don't have to be like the obtuse triangle. The obtuse angle doesn't have to be alpha.
No, it can be any angle. I just tend to draw it that way because I've done it a lot that way. So it's just these ratios. And you can use the alpha and the gamma if you need to. You can use beta and gamma. You don't have to use all 3. You just have to use any 2 of them and set up your ratio and solve it. Okay? The law of sines, here's when you use them. It's when you're given an angle and the 2 angles in the side between them, 2 angles in the other side, or there is, in geometry, you were actually solved triangle congruencies, but there's 2 cases you never solved. You never solved the SSA or the AAA. With trigonometry, we can actually solve the SSA case. We'll never, ever be able to do the AAA. We'll never, because they're all proportional, and we don't know what the rate of proportionality is, so we can't solve it. But we are going to learn a way to do the SSA case, which you weren't able to do in geometry. On 355, there's a caution that you should read. $355. It's just a reminder. You probably knew it already, but it's good to remind yourself. So what do they tell you in the caution? What? Yeah, thank you. I was like, oh. All your angles have to be between 0 and 180, and they all have to add up to only be 180 exactly. And the other picture, what they're trying to show you here is, I think, what they're trying to show, here's what I take from it, is that your side lengths also have to meet up at a vertex. Otherwise, you're not talking about a triangle we can talk about. It's not going to work. Okay? So, just a reminder from geometry, what we're allowed to do. So, let's do examples. So, example 1. Here's what they give us. They give us this angle right here is 45.1 degrees. Notice we've switched to degrees. 75.8 degrees. And they tell us this side is 10.2 inches. And when they say solve the triangle, what they want from us is they want the 3 missing pieces. They're going to give you 3 pieces, and when they say solve it, we have to find the other 3. And just because law of cosines, we have to do things a little differently, we have to notice what kind of triangle we're given. So if you look here, we have 2 angles, and do we have the side between them or not the side between them? The side between them. So we have an ASA case. And the big thing I want from this is, actually we should probably write this down on here. Look at your law of sines on your Blackboard sheet right here. The cases we get to do this with for the law of sines is ASA. What did I list them? I listed them on the other page. I should have wrote them down. ASA, angle, angle, side. And then we also have the special case of side, side, angle. So those are the three situations when you're going to use law of sines. And that's why I want you to recognize what kind of triangle you have so you know which of these laws you can use. Okay? Okay. So let's use it. So what's going to be the easiest thing to solve for? Gamma. Yeah. Because what do we know about the three angles? Make 180. So for gamma, if you just go 180 minus this angle, we got gamma. What'd you guys get? 59.1 degrees? We also need to find A and we need to find B. So now to find A and B, we're going to use the law of sines because that's the kind of triangle we have. Do you want to find A first or B first? Here's the caution. Always go for the smallest angle first. Yeah. In the smallest side is shortest side is across from the shortest angle. When you get into law of sines, when you start finding angles and stuff, if you don't know what kind of triangle you have and you got to find an angle, and if you go for the biggest one first, sometimes that can be an obtuse angle, but the law of sine is only going to give you the complement. It's not going to give you, or the supplement. It's not going to give you the whole angle. If you go for the smallest one first and then kind of go in increasing order, you're guaranteed to not goof that up. Okay? So go for your smallest one first. So that's A. Now we need to know one angle on the side across from it. So we now know gamma. And so and do we know the side across from it? Yeah. So we're going to use the sine of gamma, which we just found, and the side that we know across from it. And that equals the sine of 45.1, bless you, over A. And we can solve for A. Make sure your calculator is in degrees, otherwise big problem. Okay. How are we going to solve for A? Cross multiply. So you have A times the sine of 59.1. And that equals 10.2 times the sine of 45.1. And then you would also need to divide by the sine of 59.1. Mode. What did you guys get?
8.42.
Good. And that's in inches. And we're gonna use this same one right here, but now we're gonna use it with the B. Okay? So we gotta use the same one that we know. We have to know one of the ratios. And so we know the sine of 59.1 over 10.2 is equal to the sine of 75.8 over B. Same process. What are we gonna do? Cross multiply. And then divide by the sine of 59.1. What'd you get?
11.52.
Good. Pretty straightforward, right? right, example 2. A sundial can be used to trace a moving shadow during the day to measure time. The raised part that casts the shadow is called that. In order to measure the time accurately, the angle of the thing makes with the face of the dial must be the same as the latitude where the sundial is used. Okay. And if you look on page 357, they have a beautiful picture of it. Okay. So there's our beautiful picture. They tell us that the latitude of San Francisco is 38 degrees north, and the elevation of the sun, alpha, and they gave us a picture over here where they told us this was the alpha, this is the beta. So this has to be set at the same latitude, so that's 38 degrees. And this is the elevation of the sun, which is 63 degrees at noon. How long will the shadow be? And this is the thing that sticks up of a 12-inch, whatever that word is. And there it is.
How do we know the one with the 36, which side the 63 is on?
That's the angle of if you look at the book, if you had your book open to page 357, they in the directions it said sun alpha, and in the picture they show you where alpha is. So open your book. That's what I'm trying to tell you. There you go. There you go. It's beautiful. Okay, so what kind of triangle do we have? We have two angles and a side. It's an angle side because the side's not between the two angles. And of course, this is the first section, so we're going to use a law of science. But anyway, we need to figure out this shadow length. And so what I know an angle and a side across from it. What else do I need to know? I need to know this angle so I can use that ratio right there. So how are we going to find the other angle, gamma? Yeah. What is it?
79.
Thank you. And now we're going to use that to find our shadow length. So we're going to say the sine of 63 over 12 equals the sine of 79 over, we don't know. What do we do? Cross multiply and divide. Make sure you typed your things in right. Oh, whoopsies. What'd you guys get for the length? 13.22, and we're in inches. That's how long the shadow is. Pretty straightforward? Okay. The last case we're going to do is the SSA case, and they call this the ambiguous case. There's some little tricks with this. Okay. So, here we go. We're going to find beta given this information. Okay, so let's draw our picture. So let's draw a triangle. We want beta. They give us B. They give us alpha. And they give us A. So with that information, we should be able to find B, yes?
Yes.
Yes. So, oopsies, you can't see that. The triangle that we have, it's a side-side angle. And so let's set it up. Oh, we gotta solve for beta this time. What do we need to move first? We're solving for beta. Oh. Good. Multiply by 2.3. So we have 2.3 sine of 34 all over 1.2 equals the sine of beta. How do we get the sine away from the beta? Inverse sine of both sides. Let's figure out what that is. So, actually do it out. What happened? You got an error? I did too. This means this triangle can't be done. The problem with SSA is sometimes you can get a triangle, sometimes you can't, and sometimes we can actually get two triangles. Weirdness. This case, here's the problem. In actual, if we actually made a scale representation of this, this is really what this triangle looks like. Really, here's your here's alpha. Here's your B side. Really what happened is angle or side A isn't long enough to connect over here. He's just kind of like swinging out here like a pendulum. So though those sides and angles they gave us actually will not let us create a triangle.
So we could have figured that out before.
No, we're not going to make a scale drawing. When you get beta and it says error, that means you don't have a triangle to use. It means we're done. There's nothing else we can do. It's not a triangle, so why are we even looking at it? It's just a stick hanging off another stick dangling in the air. You know, like this. Like all like that.
Well, you could simplify the fraction part.
Yeah, this actually, when you work this out, you get 1.2. What's the problem with a ratio of 1.2 when we're talking about sines? It's not going to cross. Max is at 1. Can't do it. Bummer. Okay, let's try another one. I don't want to do this ambiguously, even though it's called the ambiguous case. What I would like you to do is if you look on page 361, you will be allowed to use this on tests and quizzes. This picture, okay? This is, you only are going to use this when you're talking about side-side angle. Here's ways that help us figure out whether we have no triangle, which is the case we just ran across. There are times when we can just have one triangle, and there's other times when we can have two triangles. Here's the important piece of information that you need to determine whether we're going to use this. We need to know the height of the triangle. And to figure out the height of the triangle, look what they give us right here. H equals B sine alpha. So to determine whether we have 0, 1, or 2, we really need to figure out whether our height is okay. So when we're using when you're given a side-side angle case, you really need to use this chart to help you. I will never ask you to memorize this chart, but I expect that you use it and know where to look. Okay? So let's do this with the next case. So solve the triangle. They give us alpha, A, and B. So first thing I would do would be like, oh, let's just draw this picture. It's 47. That's 3.7, and that's 3.5. So then I would ask myself, what kind of triangle situation am I looking at? Side angle. Oh, side angle. I know better than that. That's the ambiguous case. I better be looking on page 361 right now.
How do we know, like, how to count, like, the SSA area?
The angle's not between them. If the angle is between them, it would be side, angle, side. It's just the order in which you run into things.
It can also be ASS.
Nope, we never call it that. We always do SSA. It was an honest question. Okay. So, we came across the ambiguous case. What do I need to find in order to figure this out? The height. And the height is b sine alpha. So, the height, we're going to take our b, sine of alpha. And we're going to figure that out. I need to know what it is. So the height is 2.56. And if you look on page 361 in that upper corner, the first case is 0, A is between 0 and H. That means there's no triangle. Are you guys looking on page 361? Because if you're not, you should be. Okay. So our A is 3.7. Is our height bigger than our A? Really? Look at our height. Look at my A. Is my height bigger than my A value? No. So, okay, so it's not the no triangle case. So look at the next line down. The next one says A equals H.
No.
That's not true. And then let's look at the next one. It says H is less than A, which is less than B. Well, is B greater than my A value? Nope, so it's not that case. Look at the last one. Is A greater than or equal to B?
Yeah.
Ah, it's that case. And if you look next to it in that chart, how many triangles do we have? We just have one triangle. So we're just going to solve this like normal. Okay? So, what's the only thing we can find right now? We need to know gamma, we need to know beta, and we need to know C. I heard you guys are saying it. Beta. The only thing we can find is beta. We do know this ratio. We need this one. So, the sine of 47 over 3.7 equals the sine of beta over 3.5. No, so we need to find beta. How are we going to find beta? You can, or if you look here, we need to get things away from beta. We're dividing by 3.5, so what are we going to do? Multiply. You can do cross multiply or divide. It totally works. This just saves you one step, which I'm all about saving steps. Now, we need to get beta by itself. So how are we going to get beta by itself? Inverse sine. I appreciate the response, even if it sounds mumbly. What'd you guys get for beta? 43.77 degrees. Okay, good. The next thing we can get is what? Gamma and C. Why is gamma going to be quick? We know alpha, we know beta, we need gamma. So 180 minus the other two. So 180 minus 43.77 minus 47. I got good. And the last thing we need to find is C. So, oops. So for C, I'm still gonna use the sine of 47 over 3.7. Can you see that? Yeah, you can. Okay. Equals the sine of gamma, which we just found, over C. Now we're gonna do Beau's favorite thing. We're gonna cross multiply and divide. So you should get C is same as this. What'd you guys get for C? 5.06-ish. And what are we? Oh, feet. Good. Hmm? I mean up or down? Move it down.
So I can see.
Okay.
Move it up into this.
Thank you, Mac. Is this really for me?
Yeah.
Thank you. Did you get your provisional off?
I did.
Oh, yours is really good.
What?
What is it?
Sugar free latte, I think. Is it good?
Yeah. It's really good. Alright, did you get it, Bo? Okay. Oh, I shouldn't have used my permanent marker on that page. Sad day. Will you hand me another 6-1 off the windowsill? I gotta get a different one because I shouldn't have used a permanent marker right there. Thank you. Now I'm gonna use permanent marker again.
Could ruin this one too.
Yep. Okay, so here we go. They gave me 3 things, so let's make a picture. (26 degrees, 11, and that's 18. So we have side angle. Uh-oh, the ambiguous case. What should we find first? The height. So B, 18, sine of 26. Let's see what we get.
So do they always, say they don't give you alpha, like they give you beta instead for its angle?
They won't. They shouldn't anyway. So let's look at our cases, shall we? The first case is the height greater than alpha. No. Are the alpha and the height the same? No. Is B the biggest? Then A, and then H? How many triangles? There are 2. I'm going to show you how to find the 2. Okay? The law of sines is always going to give you the supplement angle. I'm going to say that again. The law of sines will always give you the smaller part of the supplement of the angle. Okay, it'll give you the supplementary part, the small part. Here, I'm going to do it. This is a 2 triangle case. I already have one of my triangles drawn, right? The other triangle is going to look something like this. Because this angle right here, beta, is the supplement to this beta over here.
Oh.
Okay?
So
This beta is the supplement of this beta over here.
just 180 minus beta.
Is the other angle, the other beta. And here's how we differentiate the different measurements. Notice these ones I just did beta, gamma, and C. For the second triangle, this is still 26, this is still 18, and this is still 11. What I'm going to do is I'm going to call that with a subscript 1. Oh no, they actually do it this way. They actually put they put a tick mark up on the top, I guess. It's called prime, C prime. And then, so you just put a little tick mark there to differentiate between the 2 triangles. Is that okay? Thank you, Mac.
Wait, so are those different?
Yes, they're different. They're going to have different numbers. And what we're going to do is we're going to solve this one normal, and then I'll show you how to solve this one. There's only one little difference. It's really quick. Okay, it makes sense. So let's just keep going with this guy over here. So I have alpha and A, and I have B. So can I find beta quickly? Well, relatively quickly. How are we going to find beta? Mm-hmm. Equals a sine of... Good. So multiply by 18. And then take the inverse sine. Good. Beta. Good. There it is. So. What'd you guys get for B? Or beta, sorry.
45, 28, 3.
Good. So, how are we going to get gamma? 180 minus it. 180 minus 45.83 minus 26. Did I do that right? Yeah. And the last thing we need to find for this triangle is C. And so just use law of sines again. So the sine of 26 over 11 equals the sine of 108 over, we don't know, 108.17. Bo's favorite thing, cross multiply divide. What?
I had 23.8.
That's what I got too. Make sure you didn't lose a number. And we're in centimeters. So the first triangle, exact same, yes? The nice thing is, for the second triangle, we have to do one less law of sines. Here's why. Beta prime is the supplement of beta. So that means to get this beta, what you're going to do is you're going to go 180 minus the beta in the first triangle. So beta prime is 180 minus 45.83. 134.17. And now to get gamma prime, you're just going to go 180 minus your two angles. It's going to be small, and that's okay. And the last thing to do is do one law of sines, and we'll get our C prime. Did you guys follow me on that? You guys understand where beta prime came from? Oh, 180 minus alpha minus beta prime. We know alpha, we know that angle, so just 180 minus it. So I would go sine of 26 over 11 equals the sine of gamma over C. You can cross multiply and divide. I've totally run out of room. Oh, I did it again. What did you guys get for C?
8.59.
Good. So for the ambiguous case, there are some times when you're going to have two triangles, but there's some cases when you don't have one. So there's sometimes when you only have one. Those are your options. Are you guys feel comfortable using that chart on page 361?
Yeah.
Okay.
So if you get 0, you just
You're done, yeah. I obviously did this a little bit differently than when I first created these notes. How do we find the height in the ambiguous case, the SSA case? What's the equation?
A equals B sine alpha.
Yep. Okay. And that's also listed in the very top of that chart, right? Right up here, the very top of that chart, it tells you what H equals. So you don't have to memorize it. It's there for you, okay? The last one is the cities of Jacksonville and Miami are 335 miles apart on Florida's east coast, with Miami southeast of Jacksonville. So here's Jacksonville. Here's Miami. And we know that they are 335 miles apart. Tampa is 181 miles southwest of Jacksonville. We want to know this distance, how far is this? And they tell us that the angle, if a triangle is formed by connecting along the cities, the angle at Tampa is 120.3, and so then they tell us this is 120.3 degrees. Is that okay? Yeah. Same as right there. Now, one thing with that chart on page 361, in our case, our alpha is now obtuse. So if you look under alpha obtuse, you either have one triangle or you only have one triangle. So we're just going to go with it. We're going to see what happens. Okay? And we want to figure out the distance from Tampa to Miami. So, what is the first thing and the only thing we can find right now? We don't need to because alpha's obtuse. And so we're just going to move on. Is that all right?
Yeah.
Okay. Can we find the angle at Jacksonville or Miami? Miami. Because we know the side across from it, right? So let's find this angle right here. I'm going to call it, well, I'm going to use M because we're at Miami. Okay. So we're going to say the sine of 120.3 over 335 is equal to the sine of Miami over 181. So multiply by 181 and take the inverse sine of it. And that's our angle there. Oh. What do you guys get for M? Okay, so now that we know what M is, can we figure out the angle at J, at Jacksonville? Yep, so 180 minus 120.3 minus 27.81. So J is 31.89 degrees. And now we can figure out the missing distance from Tampa to Miami. So sine of 120.3 over 335. Sine of 31.89 over we don't know what. Cross multiply divide. How far is it? Yep. So about 205 miles from Tampa to Miami. How do we feel about this? Feeling okay with this stuff? Okay. Please make sure you use that chart on page 361. Okay?